Welcome to another video from Lockdown Electronics with me, Bill. This time we've got a review and it's the Joyalens digital microscope, and I'm going to explore my FPGA board with it. That's hopefully something you're going to see appearing on the channel in future when I've got my head around Verilog and understanding the complexities of getting the code onto an FPGA, which isn't straightforward. I guess it might be for some of you, but it certainly isn't for me. Joyalens asked me if I'd review this microscope, and I said I was happy to do that as long as I could say what I liked, and they weren't asking to review the video before I published it. They were more than happy with that. So let's take a look. Okay, well, as you can see, we get quite a sizable box. It's actually pretty sturdy, and again, not complicated to get apart. Once it is open, we've got a bit of a padded lid, and the first thing that greets you is an actual printed manual, which I think is excellent, and then a list of components and assembly instructions. Now, there is a video on how to put this together, which I shall put a link to in the description. It's not too difficult, and there are already several reviews of this out on YouTube where people have assembled it, so I'd encourage you to watch them. Maybe the more videos you watch, the better informed decision you'll make about whether this kind of thing is for you. But it is well packed, foam inside, various cables here, the actual screen is there, and then underneath we've got the various bits and pieces all bagged up and labelled. Lens in a nice little plastic case there, which will come in handy to keep it in later. That's the stage for if you're going to use microscope slides. That's lit from underneath. So we will have a look at all that when it's assembled, but that's what you get. I was quite impressed with the quality of the packaging. Sometimes you get stuff from China and the packaging is a little bit what shall we say, insubstantial, which is not the case here at all. It's very nicely done, and of course you might say, well, that doesn't matter, it's the microscope I'm interested in. Yeah, but wouldn't it be good if it arrived intact? And you do quite often on some of these feedback forms, you see people saying excellent product, unfortunately arrived in a damaged box, and it's a poor start. So I don't think this is the case here. So what I'm now going to do is get it built, and then we'll have a look at the finished article, and you can refer to other videos in the assembly video if you want to see how it goes together. It's not particularly difficult, you just have to take your time. So I'll come back when it's built. Okay, well, by the magic of filmmaking then, here is the completed article. There are plenty of videos out there showing you how to put the thing together. Not that you need them, because these instructions are actually very clear, and it's not complicated, so there's no need to be concerned about assembly. It's very straightforward. So I've got the base with these two arms that have lights on them. This is the microscope itself with its objective lens here. The objective lens I've got fitted at the moment is the one that gives the smallest magnification. There are two more objective lenses that come with it, A and D. This is what's called the long one that's in. The D lens is very close indeed, the A lens is quite close, but I'll put one on and show you that in a moment. So that's all very straightforward. Currently the screen is on, so if I pop this rule under there, that's 10mm in the middle of the screen. Now what is rather nice is on the back there's an SD card slot, and although the instructions say it doesn't come with an SD card, there's a 32 gig card with it, which I've got in, and we can not only take stills, we can also record MP4 video, which for me as a content creator for YouTube is very useful. I'll certainly be using that. Now there's some buttons on the front, and you can indeed take photographs with that on. If I press that there, that is taking a photo. Obviously touching it does introduce a little vibration, so probably the far better way is to use the remote that comes with it. You will need a couple of AAA batteries to work the remote, but there's more features on the remote than there are on these buttons here. So it's extremely easy to take a photograph with the remote. You just press the red button at the top and there's a photograph taken, and pressing the OK will start and stop video recording. So let's get something underneath, and let's now have a look at the video recording options. So I'll start a video, and the red mark in the corner now tells me it's recording. So we'll swap that video by the magic of filmmaking, and you can see here I've got the circuit board underneath. This is actually my Tang Nano 9K FPGA development board. The reason I've picked this as something to look at under the microscope is that it's got some of the smallest SMD components on that I could find on any circuit board. Now the great thing about these lights is a little bit of movement will adjust the illumination, allow you to, for instance, to pick up the writing on there. That's the GW1NR FPGA itself, and then we can move around the board, and there's various components. I think that off the top of my head is to do with Bluetooth. I'm pretty sure that one is that might be power control. Coming back across to the far side here, that one there I think is flash memory, and then there are some more power control ICs. I know those two little ones mid-screen there are actually diode packs apparently. Okay, what I'm now going to use is my fine soldering tip. I haven't got it in the iron at the moment, but I'm going to use it as a pointer to give you some idea. So coming in there now is my small soldering iron tip that I would normally use for SMD devices. I'm going to just spin the board around so it's easier to get to things, but just to give you some idea. So there's a very fine tip for the soldering iron, and hopefully you can see it would be more than possible here to do work on these components like so, which I'm not about to try, by the way, and spoil my rather nice FPGA development board. So one of the things that has certainly happened in my experience is that when you start using a magnifier like this, at first it seems a little odd because the movements are very appear to be exaggerated, but it doesn't take very long for you to, for want of a better phrase, get your eye in, and you can very quickly start working incredibly accurately, and it isn't until you pull back and look at what you're actually doing you realise how fine the work is, and that definitely does occur. So if you're thinking, oh, I'd never, that hand wouldn't be steady enough, I'd persevere a bit, because you might find your hand actually is steady enough. So yeah, as you can see, so we've got all sorts of SMD devices, and some of them are very small indeed. If I flip the board over, on the rear side here we've got some very small components. I'm just going to use the hand wheel and just adjust the focus slightly. There we go. So if we now introduce the rule for a moment, I'll try and be as steady as I can. You can hopefully see that that little component there is probably about 0.5 millimeter wide. The graduations are near 1 millimeter. That's about 0.5 millimeter wide, and it's about, if I can not disturb the board, it's about 1 millimeter long, something like that. Let's go from that side so you can see it a bit better. Yeah, so it's about 1 by 0.5 millimeters, that component, so you can gives you some idea of the how close we are to the subject. So flipping back over again, then we've got some components here. I'll use my soldering iron to point. So these are LEDs. They're actually red LEDs. There's one there as well, and they're obviously surface mount, and when you're using the board they just sort of flash away depending on what you're doing, and they just appear to be a little red light. But if I now get some power, what I'm going to do is try and position that LED, just the one just below the 32 megahertz crystal, as you can hopefully see just there. That was a very large fingernail. And if I power up the board by plugging in the USB, actually the LED is now alight. If I move the lights a little bit, you can hopefully see that. Let's go along to these LEDs here. Now these will flash when I restart the board, so let's just do that. So you can see how those LEDs work, and the black spot in the middle is actually the semiconductor material that does the lighting up. Now I'm talking about that because what I want to do is I want to show you just how close you can get to these devices. So going back to the normal view from the camera here, so you're hopefully getting some idea of what it's capable of. So now what I'm going to do is swap the objective lens, and then we'll have a look a little bit closer at that LED. Okay, to swap the lens, very straightforward. I'm going to use the A objective, which is 12 to 320 millimeters object distance, and it's very straightforward to do. You undo these two little thumb screws, and the lens then just comes out like that. I'll pop it in its box. The objective lens fits in. It has got a little indexing notch, which means you have to line it up correctly. You just have the numbers at the front and that does the job. So I'll put one in, and I'll put the second one in, and I'll show you a couple of other features as well while we're doing that. So the whole thing is running off a little USB power supply. The remote here divides the supply to the microscope itself and to these lights, and there are some buttons on here. There's an on off, but there's also a button which will adjust the brightness of these LEDs. Doesn't obviously affect the power supply to that. If you're going to have this connected to a computer, then the microscope itself takes its supply from the USB connection to the computer. So what we now do is just move the FPGA board out the way for a moment, getting a bit tangled up. What we now do is we're going to undo that screw there, and we're going to move it right down. I'm just guessing for a minute. This adjustment here, the focus if you like, I've put that in the middle. I'll explain why I'm doing that in a moment. Let's twizzle it back around, and we'll just use the rule to give us an idea. We can now use the focus wheel. Could actually still be too far away. No, I'm not. There we go. Yeah, so now you can see I'm considerably closer. So let's just, there we go. So that's quite a bit closer. So let's pop the FPGA board back under. And there are those same LEDs. So it's needs a little bit of tweaking for the focus. There we go. So you can obviously it's nice and sharp now. So if I press the restart, you see the LEDs just flash there, and if I take away some of the illumination to make it easier to see, there they go. Now there is digital zoom, so you can zoom in using those keys or the remote. Obviously digital zoom is effectively a crop, so you start to lose resolution and therefore quality, but it does allow you to get closer, and that may be something that works for you. I don't know. So that's the middle distance focus. Now what I'm going to do is swap over to the very close lens, and I'll come back when I've done that. Okay, so I've now got the smallest or the closest focusing objective lens in. This clearly isn't one you're going to be using for electronics work. I'm not showing it you for that. What I'm really showing it you for is its ability to magnify. So there is one of the LEDs. You can hopefully now see. So what I'll actually do is, let's go to recording on the microscope, like so, and we'll just hop across to that now. So here is one of those LEDs, and you can see the device is occupying a fair chunk of the screen, and if I move one of the lights to one side, you'll see that it is actually on, and you can see the tiny square of semiconductor material that's actually doing the emitting, and you can see the wire coming across either cathode or anode, not sure which, but that should give you some idea of just how close you're able to magnify. Now I don't know if I'm going to be able to achieve this, but I'm going to try. Let's try and now get a rule in there for you to give you some idea of size. Try not to short the LED out at the same time. I'm not going to be able to do that. No, it isn't going to work. But if we go across, there are the other LEDs that are not lit, and you can actually see the detail a little bit better. So I'll focus in for you just to get sharp as I can, and I'll just demonstrate while we're there the digital zoom. Bear in mind, of course, we are cropping the image here, but we've zoomed into the maximum, which is 3 times there. So yeah, we've obviously lost some quality, but you can nonetheless see some detail you perhaps couldn't see before. So that's an LED, very close up. Go back to the normal magnification of just the standard resolution. Magnification is now 0. Right now what I'm going to do is show you what the manufacturer has intended you to do with this particular lens. Okay, and last but not least, what I've now done is I've taken the power supply that normally feeds the 2 LED lights, and I've attached it into this device here, which is an attachment that comes with it, and this effectively provides lighting from underneath. Now they do provide you with a number of sample slides, so this takes me back to my school days looking at things underneath the microscope. This is apparently a pine stem. These few slides come with the microscope. Appreciate it's got nothing to do with electronics, but you can hopefully see just how easy it is to look at something that's actually quite small. So I'll just show you a still image of that, and you have to bear in mind with things like this that the depth of field, or if that's not a familiar term to you, the zone of sharp focus, obviously is very narrow when you've got something that's focused so close. It's a bit more tolerant when you're on the lens, which allows you to be further away from the work. But you can see here the cells quite clearly in the centre and on the walls of the pine, and don't ask me about the details, I don't know what I'm talking about, but those are certainly cells. So yeah, that's pretty good. It's maybe something, if you've got kids who want to play with stuff like this, they'd probably be very interested in being able to see things close up. There are 1 or 2 other gruesome little things like flies' legs and things in the example slides that you can look at. I won't put you through that. I thought we'd just deal with a nice straightforward little pine stem, as it's called. So that's the scope, and this little stage here with the LED underneath is quite handy for lighting things from underneath. Now when I was using the showing you the LED close-up just now, I was using the same lens, but I was using light from above, obviously, because the light isn't going to shine through the circuit board. So a couple of things that I've not mentioned. Firstly are that there is a USB connection on the back, which is used for the power supply, but if you connect that to a computer, there is some software, and you'll find the link in the description. It's also in the manual. That software allows you to grab the image off the screen. It's Windows software. They don't think they do it for anything else. I have a sneaking suspicion that it would probably work with any webcam. I think it's a fairly standard way of transmitting an image through USB. I'm not certain about that, but I get the impression that it is. So you can do the wired connection. It has also got Wi-Fi. Now that's not something I can try out up here because my computer I use for video and for editing and things doesn't have Wi-Fi. I just use a wired connection, so I can't actually check that out, but it's certainly possible to do that. And if you go onto the remote and press menu and press it again, you can go down to the Wi-Fi setting. There the infrared receiver's on the front here, so you need to point the remote at it and it'll work okay. And then you can go down to the various things, which include things like putting a grid line on, so you can have various crosshairs if you so desire, which might be useful. And there's quite a lot of options there from the two menus. So to change menus, menu 1 and then menu 2. So yeah, there we go. The manual that comes with it is surprisingly understandable. There are 1 or 2 translation errors, but they're actually easy to work out compared to some manuals I've read where it really was very challenging to understand what they meant. This actually is quite good. So yeah, that's the Joyalens microscope. On the back as well there is a mini HDMI output. It's not the very small one, which is micro, it's the middle size one, the mini, and it does come with a lead that goes from mini to normal HDMI, so you can connect this to a HDMI display if you've got one. Again, that's difficult for me up here to show you, but I know that's appeared on other videos, so you can get a much larger display should you like. So that's pretty much everything I can think of to show you on the microscope. Okay, well there you have the Joyalens microscope. Hopefully it's been useful. Tried to look at a few things that I haven't seen in other people's reviews, so if you want to see how to put it together, there are other reviews out there that'll show you that, but quite frankly the instructions are very straightforward. I'm quite impressed with it, if I'm honest. I particularly like the ability to shoot stills and also to shoot video. I shall certainly make use of that in future videos on the channel. I do actually do quite a lot of macro photography for the channel, photographing components and things, so it'll be ideal for that, and hopefully you'll see it featured in future. I'll put some links to Amazon in the description, and I don't have any connection with Joyalens other than reviewing the product, and those links don't earn me anything, so it's entirely up to you. If you like it, have a look, see what you think. Thanks very much for watching. Look forward to seeing you on the next video.